Alright, so I was going to show you a quick and easy way to test your algorithm to make sure that it works, and to do so we're going to use a Unix program called BC. On Cloud9 just type in BC and there it is. This also works on Macs. If you're in your terminal just type in BC, there it is. It's a programming language that deals, it's really good for algorithm checking, I've found. The only quirk with it is it doesn't understand capital letters. So instead of using the camel casing notation, we'll use the underscore notation. So back in our algorithm, I said that for the widget calculation, it should be total cost equals cost per widget times widgets purchased. So I need to find out if that actually is the case. To do so, I'm going to declare the total cost equal to 15.50. I'm going to declare the widgets purchased. And in this case, I'll make up a number. I'll say 16. Excuse me, I actually miswrote that. Cost per widget is what I want, equals 15.50, and total cost equals widgets purchased times cost per widget. Now when I type in total cost, it gives me 248. So now I need to desk check that, and the easy way to do that is say 16 times 15.50, and it gives me 248. And I can tell that my algorithm works. So I'm going to type in quit. It's going to exit that, clears out the terminal, and I now know that my algorithm has been checked and that it's going to work just fine. So inside my widgets.c file, I'm actually going to write it. So the first thing we're doing is the standard input and output header. You're going to see this in every C program ever. So pretty much that just, if you want, one easy thing to do is to write out a stump. So to show you writing out a stump, right click, new file. I'll call this stump.c. Double click on it, and then include standard input output.h, int main. And here's a little quirk that I didn't talk about earlier, but you notice that we're declaring this to be the integer type main. In some C compilers, you must return a value back to this int, and that's what the return statement does here. In the actual technical C specifications, that isn't necessarily true. It should stop wherever it sees the braces end. Whenever I put my cursor on one of the braces, this little box will go around and show me where the brace is open and closed to make sure that everything is closed out correctly. So return 0 isn't necessarily a part of the C standard, but some compilers do not like it if you do not include it. So now I have a stump. I'm going to save it. So anytime I don't want to have to rewrite that every single time, I can right click and click on duplicate and then rename it, and then whatever.c. And now whenever I open up my whatever.c file, I can just begin writing with the stump already taken care of. If you start writing more complicated include statements, these stumps will come in pretty handy. But for right now I don't need it. So I'm just going to delete both these. And it should warn me, and I'll say yep. Anyway, so here we have our widgets program. I also included the string.header file, although not needed in this case, but just to show you there are other libraries you can include as part of the standard C library. Which ones you will have access to depends upon what C specification you're using. The most recent one is C11. The numbers indicate the year that the standard came out. So the C99 was the version previous to that. Then there was the C89 standard, and almost all of them nowadays, any modern compiler is going to be C11 based. But just in case, certain headers, whenever you look up these standard C headers, some of them will not be available to the standard C library, will not be available to you in older versions of the compilers. Anyway, so the first thing we see in here is we're doing another declaration. We're doing another data type declaration. In this case, we're doing a float declaration. Then we have cost per widget. Now, I capitalize the C here, even though it's not standard, only because cos is the cosine function. If you include the math.h file, then cos would have a specific meaning. It means you want to get the cosine, but in this case I don't. But the syntax highlighter is still going to think that's what I'm trying to use. It's just a little distracting, so I got rid of that. So I have a floating type of cost per widget. The float type rather, it allows you to use decimal places. So instead of just the integer type, which is whole numbers, 0, 1, 2, 3, 4, blah, 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 the floating type gives you the ability to use decimals. Now you have to be careful about what sort of float you're using. Float is just a default. There's also double, and then long double, and then long, long double. Each of them gives you more precision with how many, how far out you can go at the end of a decimal string and still get accuracy. Beyond a certain point, you will lose accuracy. And you can look up all sorts of articles that explain it in more detail. But for right now, just know that for how few decimals we have here, this should be just fine. But if we were to have a very long string here, we're going to get certain errors because some of it will not be able to be calculated with any sort of precision. Next up, we have our integer type of widgets purchased. We expect the person to enter in a whole number. You can't purchase 22.5 widgets, so the integer type makes sense here. Then for the total cost, we're going to make that a float, and the reason why is because we have the cost per widget being 1550. If we made this an integer, what would happen whenever we tried running this is it would simply cut off the .50. So by default, C always rounds down. So if you had 3 purchased, and that would give you whatever number, the remainder, the last 50 cents, would simply be 46.50, I think. That would be cut off. Excuse me. Yeah, 46.50. The last part would be cut off. It would just be $46. And obviously you don't want to lose money like that. So in this case, our total cost will be a float. Next up, I'm using another data type called the character data type. Now I'm actually making this a string. But one of the quirks of C that is really annoying if you come from another programming background, my background is in JavaScript and Python, is that it does not handle strings very well at all. In fact, it's really quite poor at handling strings, and you have to do a lot of extra code just to get it to understand what a string is. Inside of C, a string is a character array. And that's what these brackets right here are indicating. It means it's an array of characters, and I'm initializing to the value of 88. I'm saying that I will have 88 character arrays, basically. Technically, that's not true. I will have 87 character arrays with a null terminator, which is 0. And basically, in the character array, that tells it that at that point it has reached the end of the file and it should stop reading. So 87 possible characters with 1 reserved for the null character. So I then use my print function. It prints out welcome to the widget buying program. The /n means a new line. And then how many widgets would you like to buy? Then it tells them what the price per widget is. Then I'm using the scan function. The placeholder here, %d, that's a placeholder. It's saying that it should scan into memory the integer and store it into an address, and that address is the widgets purchased. Now, why is it like this? I'm not entirely sure of the exact mechanics behind this. You can ask a computer scientist more about this one. But I think that if you try to scan in an integer directly, or even a character, because in C, characters are also integers. They're just special integers, the ASCII base integers. Now you can Google ASCII and you'll see what the numbers, the integers, actually convert to and how it understands that. But anyway, the integer type, if you tried storing any number directly into the widgets purchase variable, I think it would attempt to store it directly into the memory at that particular point. So this is saying to find out where the address of this is, and not to overwrite the address, but to actually store this inside of the address. I think that's what it says. However, I could be completely wrong with that and lying to you. But I do know that if you try to do it like this, it won't work. Next up, we then print out what one word describes our awesome program. So this is where I get to the point where C sucks with strings. I'm using the scanf function, or scan function, and the %s means it's a string, and it's the string stuff. Now, using scanf is a little tricky when you're working with strings. And the tricky part about it is that it understands if you scan in something from the user's standard input, which is what that is. In programming code, it would look like that, standard input, which hence you have the standard input output up here. It would understand that whenever there's a space, so if there's two words and there's a space between them, it would think that the empty space there is the null terminator, and thus it would end the string wherever they put a space, which means you can only really have one word whenever you're using the scanf function. There are other ways around it, but that gets into more advanced stuff. So over here, just know that when using scanf, you can only get one word in there. So we're using that one word just for having a service. Then we're printing out, you said our service was %s and an exclamation mark. And then we're grabbing that variable stuff, and inside this placeholder, the reason it's called a placeholder is that this %s is telling what type of data it should expect back, and then it's replacing that with whatever variable we declare. If we had multiple character types in here, so I guess I'll go ahead and write that just to make sure. You want %, LF, nope, no, %d widgets using our awesome, no, service. It's hard to type and think at the exact same time. So now the %d is the widgets purchased, and then stuff is what I called whatever they write in there. So the first one, %d, that corresponds to where we have the comma, this particular data type, that's going to put that there, and then stuff is whatever they put inside of here. It then performs the operation where the total cost, the way it works, this is called the right-hand assignment. So it performs this calculation first, then it does the left-hand assignment, which is where it takes that and it stores it inside of the total cost. And then we print out the total cost. Now I'm using %.2. I'm not entirely sure if it's even necessary here, but that's saying only go out to 2 decimal places and write out the total cost. So now I'm inside of ls. That shows me that I have my widgets file there. I'm going to compile it, so g++, widgets, widgets.c, like so. It's going to perform the compilation, then I'm going to execute my widgets. If you hit tab, whenever you're typing something in on the terminal, it will auto-complete it to the closest match. So if I had one file called widgets1 or one file called widgets2, it would auto-complete widgets up until the 1 or 2 is ambiguous, and then it would finish it out. So then it says, welcome to the widget buying program. What widgets would you like to buy? Each widget is $15.50. And I'll say I want to buy 24 widgets. Well, word describes our awesome program. I'm obviously being biased. I'm putting awesome. But let's say great. You said our service was great. Your total will be 37.22. Oops. So now I have a problem. I didn't save it, and that's this little asterisk means. So we run into our first, not really a bug, but I just did not pay attention to what I was doing. So if I press up arrow key in the terminal, that will step back to my last thing. So once again, 24. Great. And it says, you said our service is great. You want 24 widgets using our great service. And so here I have yet another problem. I need to add the new line character, otherwise things kind of smash together. Save it again, run it one more time, and everything should be working peachy keen now. And so this time I'll say 23 just to get the floating point assignment. And then what works for some program. Meh. You said our service was meh. You want 23 widgets using our meh service. Your total will be 36.50. Now what if I remove this 0.2 here and just say I just want to return the floating type? Well, once again, recompile it, rerun it, and you see here that without specifying that it goes out to 6 decimal places. So having that in the code helps us ensure that it's more human friendly. Anyway, so there's our program. So that goes over the most basic points of designing an algorithm, of stepping through it. And what I did here, actually as you watch me work through this, would be sort of the process of iteration. You're going to make a lot of mistakes. Everyone makes a lot of mistakes when they program. It's just part of how it works. And part of that process is iterative development, and stepwise refinement. As you go through each step, you add little refinements. So for example, if I didn't have this 0.2 on my placeholder and I looked at the output and I said, you know what I got a huge list of, where is it? I got this huge list of numbers, and that's just not very convenient for the user. Maybe instead, another thing I might want to add, your total will be, and maybe put a $sign here first, so that way, save it and rerun it. Now when they do it, 23, yay, or yeah service. Now it says your total will be $36.50, and that's just a little more user friendly. So that's the process, stepwise refining it. You run the program, you see where it can be improved, and you make little iterative changes once you know the algorithm works and once you know that it's basically doing what you expect it to do. So this is a simple C program, but it actually demonstrates a lot. It demonstrates data types. It demonstrates, this is called declaring a variable. So this is whenever, excuse me, yes, this is declaring a variable. So you just say there will be an integer, or there will be a variable of type integer, and that name of that variable will be widgets purchased. This is both declaring and initializing a value. So whenever you say there will be a variable called cost per widget, it will be of type data type float, and the value of that variable will be 1550. This is both declaring and initializing a variable with a value. So there's a lot here. Play around inside of Cloud9, try writing out your own, try doing computations, and I will see you in the next video.